A student tries to simplify 3 times x plus 4, and that student gets 3x plus 4. So this is what they get right up here. That's what they get when they simplify. Now we want to evaluate both the original expression and the student's simplified expression for x equals 2 and compare the results. So I'm going to take the original expression, 3 times x plus 4. I'm going to evaluate that for 2. In other words, take that value for x and plug it in for x. So I'll get 3 times 2 plus 4 in those parentheses. Now I'll go ahead and do that addition in the parentheses first. That's what order of operations tells me to do. I'll get 3 times 6, and 3 times 6 is 18. So when I evaluate the original expression for x equals 2, I get 18. Now what I want to do is I want to take 3x plus 4, which is what the student got when he or she simplified the expression. And I want to evaluate that for x equals 2. So again, where I see an x, I'll plug in a 2. 3 times 2 is 6, plus 4. 6 plus 4 is 10. So I'm comparing the results. I look and I see that they're not the same. And what does comparing those results and finding that they're not the same tell me? Well, if the student had simplified the expression correctly, we would have the same result because the two expressions would be what we call equivalent expressions. They would represent the same value. Because our two expressions do not give us the same value when we evaluate for x equals 2, we know that it wasn't simplified correctly. And just quickly, let's talk about what it would be if the student had simplified it correctly. What the student forgot to do is the step of distributing that 3 into the x and the 4. In other words, 3 times x is 3x, and 3 times 4 is 12. So that would be the proper simplification. And we could check it real quickly by plugging in 2 for x and seeing if we get the same thing as we got over here from the original expression. 3 times 2 is 6, plus 12, 6 plus 12 is 18. So we do get the same value, which means over here in the black ink we have simplified it correctly.